Right, in this first hop redundancy protocol, we are going to see HSRP as the first protocol. Hop standby routing protocol, which is a Cisco proprietary protocol. And let's bring this internet first. Internet has got loopback IP address 3.3.3.3, 255.255.255.255. I would like to run OSPF, IP OSPF1 areas here. See, in the real network, we will have OSPF or BGP, whatever. Internet will be using some protocol to give the external routes, internet routes. Here I'm choosing OSPF. Okay, there is one more physical interface that connects to the customer down, whose IP address is 20.003. IP OSPF1 area 0. What is next? Next, here nothing to do. Let us go to R1. And also R2. Interface F00, IP address is 20.001. No shit. IP OSPF1 area 0. And interface F01, no shit. IP address 172.16.0.0, sorry, 0.10, 255.255.00, IP OSPF1 area 0. R1 is over. I'm moving on to R2. Interface F00, no shit. IP space address 20.002. IP OSPF1 area 0. Interface F01, IP address 172.16.0.11. Done. Now, what is next? See these PCs. Actually, these two are routers. I just changed the symbol, you know it. R4 is a router. R5 is also a router because this GS3 PCs are not up to the mark. So I want to trace route and show you which gateways used. So I'm using a router like a PC. And we also have a virtual PC. Now let me start the configuration from virtual PC. Virtual PC IP address. IP address is 172.16.0.3. Mask is 16. Remember, I told you we should not give gateway as 172.16.0.10 or 172.16.0.11. No, don't give. give this floating gateway. This is what we are going to configure as a gateway in all these three, so that whichever is active, that will be taking ownership. For example, if this is active router, this will respond to this address. If this fails, then this address will move to this router. This will respond. So you don't need to change the gateway every time when gateway changes. So I give that floating gateway. I'm not giving the real router's gateway. I'm not giving the real router F01 interface address. Instead, I'm giving 172.16.0.100. That's the gateway. 100 is not going to be configured by us on the physical port of router 1 or router 2. It is going to be HSRP address. HSRP address on the physical interface, not the interface IDs. HSRP group ID. HSRP will form group between R1 and R2. For that group, we are going to give 172.16.0. Now that is what I'm considering as a gateway to all the hosts down. R5 IP default gateway. What is that? See, this is how we set default gateway on a router. 172.16.0.100. And this is considered as a PC, so F00 should have 172.16.0.2. Interface F00, not shared. Okay, I'll pull it here so that you can see. Yeah. IP space address 172.16.0.2. Now, router 4 is nothing but this PC4. IP default gateway is 172.16.0.100. Interface F00. Done. Over. Now, so far, did you understand all that I did? Do you have any question? You want any clarification? Now, did I enable any OSPF in this 3 device? No, because they are host. But this 3 device knows their gateway. Will I be able to ping the gateway? No. Why? Because HSRP is still not enabled. This will be used by HSRP on the active device. So far, there is no HSRP in either router 1 or router 2. So pinging this address 172.16.0.100 is not going to happen. Not only that, you will not be able to ping the 3.3.3.3 also. Because you cannot ping gateway first place. If you don't have gateway, then how will you go to internet? Not possible. Now, are you all ready for HSRP configuration? I'm going to router 1 interface that is down 172 interface F. Right, in the previous video, we just did the background work for HSRP. Now we are starting HSRP configuration. Go to R1, that LAN facing interface. This is where we are configuring HSRP on this. These 2 ports, F01 of R1 F01 of R2. That is where we are looking for redundancy. So go to router 1's F01. IP HSR, no, IP, sorry, standby. Okay, that's the command, standby. Standby, and then give one ID. You see, you should give one ID. That ID is a number to identify the group to between which all router need to form a group to do this. Here in our case, router 1 and router 2 should form a group. So on both router 1 and router 2, we will give same ID, same group ID. We call it as HSRP ID. I'm going to give one. See, I have given one. This is very important. This one I'll show you in the MAC address. This one will reflect in MAC address. Okay, later I'll show you. And then IP. What IP you want to give? 172.16.0.100. That's all to enable HSRP. How easy it is, you see. Now router 1 will say, I am owning this address. I'll become a master. You're going to see that. You will get a log. Command is what? Standby 1 IP. That's it. It says, I'm the active member now. I'm not a standby, I'm active. Now check this one. Show standby. Show IP standby. Hey. Show IP. Okay, simply show standby. Show standby. You say, you can see here, this particular router is active router. And the group ID which I gave you, remember? One. I asked you to remember this one shown here. And this is the floating IP address, virtual IP address. And this is the virtual MAC address, floating MAC address. And this is that one which I gave. And I told you, you will see that in the MAC address. And you remember I told you yesterday 07 AC. Here 0C is Cisco and 07 AC is HSRP ID. 07 AC. I wrote this in the board yesterday. This is the MAC address of HSRP. Preemption is disabled, I told you. The local router is active. Standby router is unknown. Why standby router is unknown? Because still we have not configured R2. Priority default is 100. Now, if you go to the PCs and try pinging the gateway, you will get reachability. You know who will respond? You know who is responding? R1 is responding. You can ping 3333. You know via which it is going? It is going via router 1. How do I know? Trace and see. TRACEROUT. Hey, that's why I took router. I'm using the router as a PC because of this command. Now you see trace route 3333. I'll go meanwhile to router 4 and check whether I'm able to ping the gateway. Then I should ping this. and I don't have the default route working. Maybe I need to disable routing capability. No IP routing. Let me check. I'll cancel routing and try pinging. Yeah. So I disable the routing capability, make it as a real host. Now I'm able to ping. I'm going to trace now 3333. You will see that it will go via router 1. You see, it is going via whose address is this? It's router 1's address. All right. So this is not going because it is still a router. I should disable IP routing command. Okay, now next. Let's go to router 2, F01, and enable standby 1 IP. Same IP. What IP? 172.16.0.100. But this cannot be an active now because this is standby. No preemption. This cannot become active. This will go to standby. And this cannot use this IP address until it is standby. It cannot use this. When it becomes active, then it becomes, it will start taking ownership for this. Look at this. It is not going to active, it is going to standby. Whereas R1 went to active. Now I'm in R1, I'm checking that the local machine is the active and the standby machine is 172.16.0.11. Who is 0.11? It is router 2. That is standby. Now, going to R4 again. Still it is going via router 1. And now we will shut down router 1. See what happens. Shut down. Now R2 should become active. See, R2 has immediately become active. Now go back to R4 again. Trace route this time. It goes via 11. It's already taking. HSRP is already working. This is because of OSPF and the switch learning MAC address. Actually, the OSPF is delivering packet to this guy. The return traffic. See, but the gateway is shifted actually. That's what you need to focus. This is not HSRP problem. Okay. Now it is coming via this way. You see, it went via 11 this time. Now, if I bring that interface back, R1 cannot become active. R1 will become standby only. So without changing a gateway address for the PCs, we were able to jump from R1 to R2. When R1 failed, our traffic was able to go through R2. That is what the advantage of using this HSRP, this first stop redundancy protocol. See now HSRP in R1 shows standbys the command standby. It says that I am not an active now, I am standby. Who is active? Active router IP address is this, which is nothing but router 2. Now listen. You want always R1 to be active, R2 to be only a standby. Then what you can do is enable the preemption and increment the priority. The priority of router 2 is 100. Priority of router 1 is also 100. Now I'm going to change the priority of router 1 and enable preemption. If you don't enable preemption, then no use of enabling, no use of incrementing priority. Okay, so let's go to the interface back and say standby 1 priority 110, and preemption standby 1, preemption preempt enabled. That's all. Now you will see R1 becoming active. R1 says, you see, my priority is bigger, so I'll become active. Check show standby. You can see here, this is standby. Sorry, this is active. Local is active, R1 is active, and R2 is standby. It is because R1's priority is higher than R2's priority. Go to R2 and check show standby. It says, yeah, I'm only a standby. Active is router 1 because router 1's priority is 110. Now let's go back and trace route. Tracing the route, earlier it was going via router 2, but now it goes via router 1. It should go via router 1. And look at this, it is going via router. Now check the ARP table. Show ARP. This is the MAC address of HSRP. So you are not learning the MAC address of router 1 or router 2. You have learned the MAC address which is floating between R1 and R2. Even the gateway is not R1's IP or R2's IP. It's floating. Now let us shut down the port again. Interface F01. Shut down. Now what do you expect? You expect R2 to become the gateway. Yeah, it says I am active now. Because the hello packets are sent every 3 seconds, you see? The hello packets are sent every 3 seconds. Whole time is only 10 seconds. So in 10 seconds, the role change will happen. As soon as R1 goes down, next 10th second, R2 will become active. Show standby, R2 is active now. Because standby is unknown, R1 is gone down. Now go to R4 and trace route. Earlier it was going via router 1, now it should go via router 2. Yes, it is going via router 2. If router 1 comes back, what do you expect? Someone answer. If router 1 comes back, what do you expect? Correct. R1 becomes gateway. Let us check now. See, I have said no shutdown. The link has come up. Listen, immediately it is active because the preemption is on and the priority is increased. Now let us go to R4 and try tracing route. Instead of 11, it should go to 10 now. Yes, it goes to 10. You did not change any gateway. Automatically, it goes because the gateway is changing. The floating, it is a gateway, a floating gateway. Our table is still having the same MAC address, same IP address, no change in the gateway, no change in the MAC address. But still, you are able to go between R1 and R2, jump between R1 and R2 without any change in a MAC address and IP address. It is because of this HSRP, first of redundancy protocol, HSRP. If you want to change the timer and all, you can change. Now, let us move on to VRRP. I'm going to remove HSRP and put VRRP here. Not here, sorry. R1. No standby 1. It will remove all the configuration. Also on R2. So now if you type show standby, nothing, nothing. Let us try tracing now. No, don't try tracing. It will be keep on showing star. Let's try pinging. The ping won't happen. What? The ping is happening because of the buffer, but we need to clear. Uh-huh. So it is still holding this. And this MAC address on the switch is registered to R1 side. That's why you are able to ping. But if you clear the MAC address table or clear this ARP table, this won't work. Clear ARP. Okay. Now that ping will not happen because that gateway doesn't exist now. HSRP is removed. That MAC address is also removed. You will not be able to ping now. From nowhere you will be able to ping because that gateway doesn't exist. I'm going to enable VRRP. See how to enable VRRP. In VRRP, preemption is enabled when the priority is same. It will check the IP address. This router 2 has got big IP address, so router 2 will become the master. See, in HSRP, we say active. Here we say master. In HSRP, we say standby. Here we will say backup. R2 will become master because of the bigger IP address compared to R1's IP address. In VRRP, preemption is enabled. But the priority is same, 100, 100 on both. If priority is same, it will check the IP address. HSRP will not check IP address, it will only check priority. Now, let's put HBRRP configuration. On R1, I say interface F01. VRRP 1 IP. See, instead of standby, the word standby, you put VRRP. For HSRP, there is no command HSRP. You say standby. But for VRRP, you say straight away VRRP1 IP 172.16.0.100. That's all. Now you will see this becoming master. First it will say I am backup, and then it says no, I am master because there is no competitor. VRRP will send hello every 1 second. So this is more faster than HSRP, but HSRP timer also can be changed. Now on R2 interface of 01, I say VRRP1 IP address is 172.16.0.100. You see, this will become master now. First it will say backup because the preemption is enabled. It says I am master. And if you go back to R1, it will say someone has taken my mastership, so I'm going backup. Yeah, because preemption is enabled on by default. I want to show you that. The verification command for VRRP is show VRRP only. Show VRRP. You see here, this is the master and this is the IP it is using, and 5E00, and this 01 is the group ID which we gave. And you see the packets are sent, the advertisements are hello packets are sent every 1 second. Preemption is enabled, the priority is 100, the master is local, the backup is the other router. It's not showing that info here, but if you go to router 1 and check show VRRP, you can see that the master router is this guy, and this one is local one is backup. All right, now what? Verify. Now you ping 333, you will be able to ping. Now you trace route. If you trace route, it should go via router 2. Yeah, it goes via router 2. You're able to ping this gateway, and if you trace route, it will go via router 2. You know why? I did not disable that routing, IP routing command on Alpha. Oh, this won't stop. Anyway, we know the concept. Now, let us go to R1 and R2 and shut down the interface to check whether R1 becomes master. It will become master when we shut down here, and it will become very fast. Actually, less than 3 seconds. See, this has gone down, and R1 by now, yeah, it's already master. Now go to R4 and try tracing. It should go where router 1. You see, goes where router 1. Gateway is already changed. Now this is because of convergence, OSPF convergence. The switch, on the top between R2 and R1, which connects to the internet, it's not the real switch. That's why this convergence delay. Okay. Now let us bring the interface up. You will see R2 will become active again, the master again. Yeah, it has become master again. Now trace the route. It should go through 11. Yeah, it is going through 11. So we have covered HSRP and VRRP. Now I would like to show you the timer. Show VRRP. Sorry, not here. This is PC. Here. Show VRRP. You see, the timer is 1 second, but the downtime or dead time is auto-calculated. You cannot configure this. Based on what is advertised time, this will be calculated. Say, for example, I'm going to interface F01 and say VRRP 1 timer. Which timer? Advertised timer. What do you want? You want in millisecond? Yes, I want in millisecond. How many millisecond? Let me say 250 millisecond. Now, when I change the advertised time from 1 second to 250 millisecond, which is 4 times lesser, 4 times quicker, you see this timer changed. Because I changed this one, this changed. Earlier it was 3 seconds, 3 point something, you see? It was 3 point something when it was 1 second. Now it is 0.25 seconds, so it is 1.3. What I'm trying to say is in VRRP, you cannot change the downtime. You can change the hello time. Hello time is called as advertised time here. Now, if you change in one router, it is recommended to change in other router also. So, advertised time 250 milliseconds. I have changed in both the routers. Right? I have changed in both the routers. Now, Let us go back to HSRP and change the timer in HSRP. I remove VRRP now. No VRRP 1. All right. I also want to refresh the cache memory here. Okay, it is gone. Now we will not be able to ping or trace or anything. Uh-oh, I should have tried pinging. This trace will never work. Here, first thing I want to do is no IP routing. Now try pinging from here. You will not be able to ping the gateway. 172.16.0.100, that gateway doesn't exist because we removed VRRP. Let's go put HSRP. Standby 1, remember, standby 1 IP address 172.16.0.100. Repeat the same thing on R1. Then now let's go to router 5 and try pinging this address. You will ping because we have enabled HSRP just now. Yeah. It will ping. ARP should get response, only then it will ping. It's pinging. Now ping 333, you will be able to ping. Trace 333, you can see that it is going via R2 because we configured R2 first. So that has become active. And we don't have preemption. That doesn't matter. We already checked preemption. Now check the timer here. Show standby. The timer is 3 seconds and the whole timer is 10 seconds. You can change this in millisecond if you want. I can show you that. Interface F01, standby 1 timer. What do you want? You want in seconds or millisecond? I want in millisecond. 250 millisecond for what? For hello. The first one is hello. 250 millisecond. And then again, I want in 1 second the dead timer. Whole time. 1 second. So you can change the whole time here. I would like to put the same configuration on R1. Now let's go and check the timer. Show standby. See, the timer is changed from 250 millisecond from 1 millisecond, 3 millisecond to 250. Earlier it was 3. I'll show you. Earlier it was 3 seconds and 10 seconds. Now it is 250 millisecond to 1 second. Timers can be changed in HSRP as well as VRRP. Show standby. We have changed. Right. Any question? Okay. What we are going to see in next class is GLBP. See, if this link goes down, you see that the gateway gets switched to this link. But what if this link goes down? I repeat. If this link goes down, will the gateway shift from here to here? No, it won't. So what we can do is we can trace this port. That's what we are going to see in our next class. We can tell this HSRP here, you trace this port. If this port goes, then you shift here. So that if this or this, if any one goes down, HSRP can shift to another gateway. What we have learned is only this one. If this goes down, if this is active, and when this link goes down, this becomes active. That's what we saw. But if this link goes down, that won't work. We need to tell HSRP to trace this also, which we have not done, which we'll be doing in our next class.